Thanks everybody for joining us. My name is Sue Dengenis. I'm the Director of Marketing here at Synchro. And today we have a very special guest presenter, Dominic Wind. Dominic is the 4D coordinator for the 14.8 billion pound, I keep saying dollars, billion pound Crossrail project in London. And it's an extremely complex project, as you can imagine, with all the underground challenges. But they've successfully pioneered the use of a number of new technologies, and 4D and Synchro being one of them. So today, Dominic's going to give you an overview of his experience with project tracking. I'm going to turn it over now to Dominic, and we'll get started.
Excellent. Yeah. Thank you, Sue. Yeah. Hi. My name is, as Sue said, is Dominic Wind, the Crossrail 4D coordinator. And today I've got a sort of presentation that's about half hour, just sort of focusing on where we are as a project at the moment. We're sort of right in the middle of MEP fit out on our project, and one of the most important things to our construction teams and our sort of senior management is really keeping track of where we are in terms of progress. So, just before we start, a little introduction in case anyone hasn't heard of our project. We're Crossrail, the delivery arm of our newly renamed, it's actually going to be called the Elizabeth Line. So it's a new higher capacity railway for London and the South East. There's 40 stations in total, 10 brand new stations. This little graphic shows you there, if you see the pink, effectively that's new tunnels. So by and large, everywhere there's pink on that station is pretty much under the centre of London. As I say, we're currently sort of pretty much done with the heavy civils and structural work, and we're really sort of in the middle of MEP A fit out. And moving forward to sort of dynamic testing in the next sort of 6 months or so. So as I say, what that means is we've moved from a world where progress was probably quite, I wouldn't say easy to capture, but it was certainly a lot more achievable. In the civils world, you know, a wall is a wall. When you move into the MEP world, it becomes a lot more subjective and a lot more fluid. So the first slide here really is just trying to introduce the problem that we sort of face most days. So changes, as we know, happen constantly throughout lifespan of any project, and it's important to understand those changes. And what I mean by that is how it came about and what impact that change has on others. We're not necessarily trying to control change at this moment, although it is very beneficial, but before we get to that stage, we really have to understand it, what it is, and whether it is actually an acceptable change or not an acceptable change. These changes, roughly speaking, sort of fall into two kind of categories. We have the sort of design change world, and then we have the field change world. An example of those are listed underneath, but just to pick out a couple of them there. You know, when we move through to sort of contractor design optimization, when they're sort of finalising routes of tray, when they're deciding what size of kit they're going to put into there, there's a lot of change happening very quickly. And then you sort of couple that on top of the field change. You know, someone could potentially have built the wall slightly in the wrong place, or there was a lack of understanding on the following trades. What I mean by that is that someone could potentially decide to move a piece of kit a certain distance without really understanding that has impact on other people, and that problem sort of snowballs and gets worse and worse. So why do we need to track progress is where I'm going to come on to now. So really, as the design sort of moves through its natural life cycle, it is very important, as I say, to keep track of these changes, and it's very easy for the intent of the design to slip. And as we found on our project, that as it gets closer and closer to construction, the visibility of that change and the ability of a company like Crossrail to assess that change reduces. As I say, it's mainly due to construction being such a fast-paced activity. They don't necessarily have time to sort of ensure that all parties are completely happy with the way things are going, with the changes they've decided to do. And this problem is definitely amplified in the MEP world, in part due to its high reliance on other interfaces, and also the sort of flexibility that's kind of inherent within the design and installation. So an example of that, when you're in the civil structural world, a wall by and large will only really go in one place, and there's not a huge amount of people that will need to sort of interact with that wall, like use that wall in their daily jobs. However, in the MEP world, that tray can potentially move several meters and still sort of fulfill its intent, its design intent. It still will carry cables from point A to point B, and it's also used by sort of multiple parties throughout its life cycle, not just the design and construction life cycle. So what that means really is the one discipline excuse me, that's really the most flexible and the most likely to change is also the one where those changes are felt, or that it has an impact on the most amount of people. So it's important to try and capture that early and try and assess that change before it gets too far down the line. What this slide is really sort of trying to introduce the problem is that this design that I keep talking about, it really comes in a multiple of different mediums. So we've got 2D drawings, we've got 3D models, you can have schematics and specifications, and every sort of subcontractor or designer within the project can have his own versions of this. So I mean, we might give them a baseline for them to start their design on, but then they can go off in multiple directions, and really they should all come back coordinated. But as we get closer and closer to that construction, that actual point of installation, the pace gets faster and faster, and it gets harder and harder to coordinate that. And really, I guess what that's saying in brief is that BIM, as we call it over here, or just a coordinated design, is very difficult to achieve, especially over when you take the life cycle of a design. It's quite easy to do it in the early stages of the project. It's very difficult to do it towards the end when it gets really, it's really vital. And you have certain tools like Project Wires and the likes that are meant to limit this, but it's really only in the early stages that you can really get a handle on it. This issue is then sort of added to by the sort of added complication of a construction program. I put down there in the bottom of that slide just a simple P6. So now what you're trying to do is not just coordinate that design in a space, you're now trying to coordinate that design in a space and time. So it just adds another layer of complexity. And then the last sort of factor in this is field change, and we've got a picture there of our installation in our Blomfield Box project, which is on Liverpool Street, and that's actually a picture of the same drawing that you see in the top there. So the design can take many flavors and many mediums, and you have to kind of bring that all together to understand it. So in short, the real problem we're trying to solve here is that anyone who has any kind of responsibility to verify any kind of installation for either quality or progress reasons has to have a huge understanding and has to has a sift through a huge amount of information to even begin to make a call on whether that is acceptable to us or not. There's a very fine line in some cases between something being installed and something being acceptable. Things can move sort of 10 mil and it means it's no longer acceptable to us. Whereas in other places things can move meters and still be acceptable. So inevitably, because the field engineer in our case has to sift through this huge stack of information, it leads to assumptions and educated guesses, which means that sort of any information coming back from site is sort of traditionally taken with a pinch of salt, as we say. So now we've kind of introduced that problem. The problem is that information coming back can never sort of 100% be trusted. We're now going to move on to how we look to try and improve that. So how can we gain more trust in our progress figures that are coming out? And really on our project there's only two paths that we can take. There's either the sort of traditional method of marking up a drawing with either a highlighter, or some people are using sort of a semi-smart PDF type markup, but it still takes the same basic form, 2D drawing marked up with progress. Or we can try and use the 3D model to try and produce some sort of visual clarity on where progress is. So depending on the scopes of works that needs to be checked, either method could work, but there are obviously sort of drawbacks to the traditional method. The first and I guess the most fundamental is that drawings can be hard to understand, especially if you're not familiar with the works or familiar with what they're trying to convey, and this causes issues with the person tasked marking them up. You know, it's the question sort of, do they actually understand what that drawing schematic is trying to convey? You know, for example, do they know that that drawing is actually saying there's 4 layers of tray that need to be put in here, and by the way the bottom one needs sort of serrated washers because of a specific specification buried at the back of that huge stack of specifications you got from the client. And then secondly, once you've marked up that drawing, it's then does the project manager, does the area director, do they understand what you're trying to say with that? So you may have a sort of a key or a code to marking up, but then you've got to try and convey that to other people. So again, inevitably what happens is the markups will never go further than the field engineer, maybe come back to the planner, but from then on it's just sort of word of mouth. The field engineer will tell you you're 20% complete, you're 30% complete. With the model-based markups, we don't necessarily have that issue, as it's a lot easier to understand. You know, same thing, we'll still have a key, but everywhere that's green you know is installed correctly, you're happy with it. Straight away you get the sort of the visual impact, you know where that progress is, where it isn't, you know if there's issues, you know if there's not. Those changes can then be sort of taken back and understood whether that change is okay. So what I mean there is the field engineer can go down, check what should be put in a lot easier against what's being installed, and he can make a call whether it's yet 100% okay, or you know there's a question here. And that doesn't necessarily mean that it's wrong. It just means that he needs more information, so he can go back, find the specs he needs, find the the drawings he needs to really make a call on that. But it gets that it gets the ball rolling on that decision making process. You know, is this okay or is it not? Whereas with the marked up drawings, the tendency is just to sort of label everything in one block. All of this stuff is installed or it's not. And this is really where Crossrail use Synchro site, the app, to really sort of benefit us, because there isn't another app that can do this for us. There's no other app that we're aware of that will give us the level of information and data exchange that we need to be able to put the relevant models out to the field engineers and them to tell us back, yes, this is what I think my site looks like at the moment. So the real benefit we get with site is that it's so much quicker to portray the same message. They're trying to say the same thing, marked up drawings and model-based tracking. They're saying the same thing, but with the marked up drawings it takes up, could be 10 times longer. So for 2 of our sites so far, which our Liverpool Street project and our Whitechapel project, and all the various contracts that are contained within that, we've decided to go down the model-based markup route, and that's got a lot of traction. There's a lot of people getting quite excited about that. There's a lot of people asking for it on other projects. But this next sort of set of slides, I just want to sort of go through a couple of the challenges that we experienced on the way to getting those up and running. So we decided to track progress. We decided to use Synchro Site. Obviously, we use Synchro Pro to sort of collate that progress coming back, and then just running reports using the sort of image production tools within Synchro Pro and using Excel to sort of quantify. But the biggest issue that came up instantly when we started was we have a visual representation of progress, but you're still relying on someone coming in and making an assumption, that looks about 50% complete, or it looks about 20% complete. So the first thing we got back from our planners was that no, that's no good. They want quantities. Now anyone that's sort of tried to harvest quantities from any kind of model successfully and completely will know that this is quite challenging. Even though we're in this world now where we have sort of BIM tools that should be able to push this data around, it doesn't always work, and we don't always get the quantities we need, especially when we come to sort of real world examples. So we have a combination of Bentley, Revit, or CAD MEP, Tekla, all of these different formats flying around, because we have to live in that world. Because construction is so fast paced, you can't mandate that there's only one kind of format. So we had to find a way to quantify, and the reason being that the sort of the real example of this issue there is that drawing on the left is a HVAC run of a sub area of one of our floors, and basically there's 7 individual runs of HVAC within that. Now we come back from, or the field engineer will go out and say that one of those runs is now installed and push that back, but it's not right to say that run is now 1/7 complete. Sorry, that part of HVAC is 1/7 complete, because obviously they're different lengths. So unless you've got the quantities in your model, unless you've got a workflow to push those quantities to where you need them to be, you won't know that actually you're not 1/7 complete. It's actually more like 10% complete there. So you'll give misleading information if you don't push quantities into that. So that was really the first challenge. We cracked that and we got that in, and everything was good, everything was great. However, the next challenge that came up was summed up really, hopefully summed up with this slide. So we solved the problem of actually quantifying progress, but then actually we found a much more fundamental issue, but it didn't come up until afterwards. And the short way of explaining this problem was that when we tried to combine multiple data sets, there's a fundamental mismatch between how different people in different jobs classify the data they're using. So if I give you an example of a real world problem, from our project, the field engineers are essentially sort of following the contractor's foreman's plan of work. So they're going out, the foreman are deciding that they're building in one area of the station. The planner's then trying to take that information and assign that or associate that to a baseline task. So in this case, he's got task for MEP in the Blomfield box. So the first question there is, well, how do I associate that I'm doing this work over there on level +1 against this really big high level task, other than to say, well, you're 1% complete out of a 2-year program. It doesn't give you enough granularity. Then you can sort of compound that, because the cost guys are trying to compare that back to a scope of works that in our case was called subcontractors fit-out works. So you've got a cost code or a cost activity that you can't logically associate to a task, which you can't logically associate to a scope of works that's being done on site. But it's only after we've sort of given them the next level of detail that this issue really comes to light. When you're up at the high level, when everyone's working off that high level agreed timeline of we're going to be doing works in this box for 2 years, it's not that hard, it's quite easy. When you come down and say, right, well, now should I be finished on this level or should I be finished on this level, the level of detail you need across the board to be able to say that goes up exponentially, which increases everyone's work. So you really then need to start making a call on, well, how detailed is too detailed? What do I really need to get out of this? So we found a sort of a happy medium, a place in the middle. The contractor doesn't need to be too specific, tell us exactly what he's doing day by day. The cost guys don't need, literally nuts and bolts prices. They just need it at the same sort of matching level. And then everyone can sort of go forward and use the same data set. And just aligning that saves so much time in sort of not arguments, but disagreements between people. Cost guys think we're 10% complete, but field engineers think we're 20% complete. So the end result, so what does that actually sort of look like? What we actually trying to sort of achieve at the end of it is really this. So in this one slide, we've got here an extract of our report. So you can see on the left there, we've got S-curves. S-curves are driven off of our real-world data. So you can see, are we behind? Are we in front? Once we've aligned that level of detail within our tasks to our level of detail that we need from the field engineers, we can then start to say with quite reasonable accuracy, you are behind or you are in front. We've then got tables there at different level of details for different audiences. So the first page is really your summary page. That's your area directors, your project managers. The next page, the one in the middle there, is a level of that same box. So what we're saying there is, okay, you may be 20% complete in the box as a whole, but on this particular level, you're actually doing really well. You're 82% complete, so that's really good. So that's great for the construction managers and the planners when they're trying to hit sort of key dates, when they're trying to look at handovers to follow on contracts. You may only need to hand over sort of 2 levels of your structure. So that really gives them the detail there. And then the page on the right is just a sort of another view of that, but this is actually in our platforms and tunnels. So that's just showing you again visually, okay, you're 82% complete. Where does that 82% actually look like? Is it all the easy bits? Is there really hard bits left to do, or is it the other way around? You've only got a few lengths of tray to go in and you're finished. And then this really sort of just illustrates that's the range of reports that we're putting out on a weekly basis. So there's me and another guy. There's 2 guys in our team that produce these, and there's actually a couple more. We've got 3 or 4 more it just being finalised now. So if you can get all of those challenges, overcome those challenges that we talked about earlier, if you can align your data sets, if you can get everyone on the same page to be able to produce these reports, 2 people can sort of put out, up to sort of 12 quite detailed reports per week, just to give you sort of some idea of the sort of value of these. There's about close to £3 billion worth of work within these reports. So it's sort of no small task to get these reports out, but if you align yourself correctly, you can do that. So that's it. That's a very sort of quick whistle-stop tour on how we approach the problem of tracking progress on these big jobs, the challenges we came up against, and hopefully a little bit, although it's hard to go into the real detail, but a little bit on how we sort of solved those problems.